Did you know you only need two things to write an equation of a line? It's true, a point and a slope. Hi, I'm Jen from Calcworkshop, and this lesson is all about point-slope form. We're going to be able to find our slope, pick a point, plug it into a formula, and we can find quickly and easily how to write an equation of a line. We're also going to look at how we can transform that line into slope-intercept form, standard form. We're even going to investigate parallel and perpendicular lines as well. So stick around. All right, we are going to learn how to write an equation of a line using point-slope form. We've already seen what slope-intercept form does for us. It helps us to graph quickly and easily. We've seen standard form, which is a nice way of organizing our variables on one side and letting that constant be on the other. But writing an equation of a line is so nice and easy when we have the ability to pull a point and a slope and put it together. The cool thing is you already know the formula, and I'm going to show it to you. But before we get into that, let's talk about the formal definition of what point-slope form is. So a non-vertical line that passes through the point x1, y1, and a slope m is written in the form of what's considered point-slope form because, again, we're given a point and we're given a slope, so it's pretty nicely named. And we say y minus y1 equals m times the quantity x minus x1, where x1 and y1, so these two little guys right there, are the point that's given. X and y, these two guys right here, are variables, and they represent all the other points on the line. So what you're really seeing is that this x and y are the only variables. x1 and y1 are numbers. They represent a given point. M is also a number. It's a constant. It represents the rate of change of the steepness of the line. Now, I told you that you actually know this formula, and you do. So here's what's so neat about point-slope form. All right. You know that m equals y2 minus y1 over x2 minus x1. We learned that we were talking about how to find slope, the rate of change. Now, I'm just going to change this ever so slightly. Instead of being y2 minus y1 over x2 minus x1, I'm going to change this to be y minus y1 and x minus x1. It's still x being with the x's and y's being with the y's. And here's what's so neat. I'm now going to cross multiply. If we cross multiply, what's about to happen is that we are going to move this entire denominator x minus x1 to the other side. So what happens now is that we have m times x minus x1 equals, and again this would be a value of 1 if we kind of put it as that fraction, 1 times y minus y1. Well, if you look at that, I'm just going to put this one first in terms of organization. We have y minus y1 equals m times x minus x1. All we did to get from one to the other was rewrite it. So really, you already know this formula. It's just the slope formula, just rewritten. All we did was take this entire quantity and move it up across the equal sign, as we know how to do via cross multiplication. So m times the x's equals the difference of the y's. This is point-slope form. Pretty straightforward. What we're going to do now is we're going to write the equation of a line, because that's the point of point-slope form. The whole use of it and the reason why we love it so much is that it really does enable us to find the equation of a line so quickly and easily. So we're going to write the equation of a line given a point and a slope. So this is the easiest way of writing it, and the slope is already found for us, and they're giving us a point. All we got to do is drop things in. We will eventually kind of get a little bit harder where we're going to have to find the slope, but not so bad. We have our slope formula to help us out. But this is the beginning of how we actually write lines. Now, before I jump into these questions, I do want to tell you a connection that I want you to make between just understanding writing an equation of a line into how this connects into future mathematical learning. So point-slope form is the conventional way of writing or saying this formula, y minus y1 equals m times x minus x1. But you are going to find later on in your mathematical journey that this will also help us find what's called linearization, or linear approximation, finding the approximate values of points on a line. We're going to be using this form in particular, as well as later on in your mathematical journey in calculus. You will also find that this form, point-slope form, is also referred to as the first-degree Taylor polynomial, that you are actually using the same formula that you're learning today, and you're going to be seeing it over and over again for uses later on in your mathematical career. Nothing is changing. This is the form that you're going to be seeing and be working with. And so it's such an important and foundational equation or formula that I want us to connect that to your future learning. So you're going to see this again when we talk about linear approximation, approximating, estimating other points on a line, when we're trying to find sequences and series and partial sums. You're going to be using this formula in particular over and over and over again. It's that important. So let's jump on in and really get a handle of what this really means. So we're going to write the equation of the line for the given form. So here's what's really important. We have a formula, and this formula says y minus y1 equals m times x minus x1. This is the m value, and we're going to take that number and we're going to plug it in directly into that formula. But this point, who do you plug it into? Do you plug it in for the x and the y here, or the x1 and the y1? You always plug it into the one with the subscripts. So this is the x1 and this is the y1. You're going to take this 3 and you're going to plug it in for the x1. And you're going to take the 6 and you're going to plug it in for the y1. Notice that x and y without the subscripts are the variables. You have to have variables in your equation, and everybody else gets substituted. So what we have is y minus y1 is the value of 6, and then equals m, which is 2, if I can get the cap off, and then times the quantity x minus, and then x1 is the value of 3. And this is the equation of the line in point-slope form. We wrote it. We found it. If we want to go ahead and sketch the line, we'd probably want to get into slope-intercept form. But we're able to do so much with it, and all we had to do was recognize what we were plugging into and drop them into the formula just like that. Let's look at the next one. So what we have is we have m equals -5, and we have at one given point of the value 4, 2. So once again, we have the formula y minus y1 equals m times x minus x1. The slope, which is provided for us, gets plugged in for m. And then what we have, and I'll use a different color for these two values, we have x1, and that value is going to get plugged in, for x1. And we have y1, which is the value of 2, and that's going to get plugged in for y1. All we're doing is plugging in exactly the way we see them and changing and evaluating by replacing the variable with its numerical number. So we have y minus y1, which is the value of 2, equals m, which is -5, times the quantity x minus x1, which is the value of 4. And that's all we have to do. Pretty easy. Now let's look at question number 3. We have m equals -1, and then again we have the ordered pair 2, -3. So we have y, I'm going to kind of move that over, y minus y1 equals m times x minus x1. We have m, which is -1, and we're going to make that substitution. We have x1, which is the value of 2, and we're going to make that substitution in for x1. And then we have y1, which is a value of -3, and we're going to make that substitution. We're only replacing those specific variables that we see in the formula. So we have y minus y1, which is -3, equals m, which is -1, times the quantity x minus x1, which is the value of 2. Now, normally, for the last couple questions, we were done. There's nothing for us to simplify. But there is something that we should probably do in this particular equation. What we're seeing when we've plugged into the formula, we've got a double negative. We don't want to leave the double negative. 2 negatives, we know, make a positive. So we will change this to say y plus 3 equals -1 times the quantity x minus 2. And this would be the equation of our line in point-slope form. We did our due diligence and we changed the double negatives to its positive. So again, we're not changing the signs, S-I-G-N, we're just changing the y1, the x1, and the m by plugging in those values. So let's look at question number 4. Once again, we have the formula y minus y1 equals m times x minus x1. So m is given by the value of 2/3. Does it matter that it's a fraction or that it's negative or it's positive? Not at all. We're just going to plug it in. It represents the steepness, the rate of change of our line. Now, we have x1, which is -1, and we're going to plug it in right here for x1. And then we have y1, which is -10, and we're going to plug it in for y1. So let's go ahead and do that. We have y minus y1, which is -10, equals m, which we see is 2/3, times the quantity x minus x1, which we see is -1. Now again, if there was no simplification to be made, we'd be done. We'd box it and walk away. But we do need to simplify this. 2 negatives here make a positive, and 2 negatives here make a positive. So we would say this would be y plus 10 equals 2/3 times the quantity, and here again 2 negatives make a positive, x plus 1. And this would be the equation of the line in point slope form. All we're doing is representing the equation and plugging in the given values that have been provided for us. Now these questions are really straightforward because the m, the slope, was given and we were given the point. We were given the 2 things we needed. Let's look at how we're going to find or be able to plug into our formula when we don't have all of the pieces readily available and we need to find it. All right, so how do we write the equation of a line when we're given 2 points? Well, step number 1, find the slope. And we know how to find the slope given 2 points. We just go y2 minus y1 over x2 minus x1, simplify, and we have the slope of our line. It should be a constant value, either positive or negative. It could be a fraction, but we find our slope. The second thing we do is we pick one of the 2 points that are given. It doesn't matter which one. Pick the one you like the best. Typically, we like to choose the one that has the most positive values or the easiest to plug into, but it's not going to make a difference which point you pick. You just got to pick one of them. Remember, you're given 2 because we're finding the slope. So you're given 2 points, just pick one of them. And then the final step, take the value you got from step 1, finding the slope, take the point that you chose, and plug it into the formula y minus y1 equals m times x minus x1, and simplify. It's that easy. So here's the first question. It says write the equation of the line, and then we're going to sketch it. So you're given 2 points, 6, -8, and 3, 4. Now on the previous 4 examples, we were given the slope and a point, and all we had to do was just drop it on in. But here we have just 2 points. We need the slope and a point. So we first need to find the slope. So step number 1, we are going to say m equals y2 minus y1 over x2 minus x1. So let's label this. What we have is x1 and y1, and this would be x2 and y2. And I'll use different colors here. And why would they be labeled that way? Well, this is the first point, so they get subscripts of 1. This is the second point, so it gets subscripts of 2. It's that straightforward. So all we got to do is drop everything in. I'm just going to put our framework in. So m equals, there's the division bar, subtraction, subtraction. Here we go. We're going to say y2 minus y1. So y2 and y1. So y2 is 4, and y1 would be -8. And then we have x2 minus x1, so we've got x2, which is 3, and x1, which is 6. All we got to do now, simplify it. So 2 negatives here we know make a positive, so we'll change that to a plus. 4 plus 8 gives us the value of 12. And then 3 minus 6, well, 6 minus 3 is 3, and we're going to keep the sign of the negative, so we'll say -3. Now 12 divided by -3, we know we can simplify. So we get m equals -4. This is the slope of our line. So now we found step 1, we found the slope. Now step 2, we need to pick a point. It doesn't matter. We can pick the first one or we can pick the second one. In fact, I'm going to show you that it's not going to matter. So let's just take the first one. It's the first one here, so might as well grab it. So I'm going to pick 6, -8. Okay? So now, step 3, all we got to do is drop it into y minus y1 equals m times x minus x1. Well, our slope, which we see right here, is going to go in quite nicely. And our x1 and our y1 are going to go in for those values that we see here. So let's go ahead and make those substitutions. What we see would be y minus y1, which we see as -8, equals m, which is the value of -4, and then times x minus x1, which we see as the value of 6. Now, this is the equation of the line, and it's fabulous. In fact, that's really all we had to do. But it does say we need to sketch it, so we probably need to fix this. So let's figure out how we fix it. Notice that 2 negatives here do indeed make a positive. So I'm just going to kind of rewrite this and say this is y plus 8 equals -4 times x minus 6. Now, to sketch a line, we always wanted to get into slope-intercept form. So slope-intercept form is y equals mx plus b. So we need to simplify this just a tad. First thing I would do, I would either move this 8 over or I would distribute and then move the 8 over. It really comes down to your preference on which one you would rather simplify with. So if we move the 8 over first, and we say -8, -8, what we have is y equals -4 times the quantity x minus 6, and then minus 8 hanging out on the end. We need to distribute this -4 into our parentheses here. And so we have y equals -4 times x is -4x. -4 times -6, 2 negatives make a positive, and we are left with a positive 24. And then minus 8. We need to simplify. 24 and -8 can be simplified to the value of 16. So y equals -4x plus 16. It's the same equation, just written differently. This equation, y plus 8 equals -4 times the quantity x minus 6, is the same thing as y equals -4x plus 16. Same exact equation. So now let's go ahead and graph it. Here's the x-axis, here's the y-axis. Now notice as well, I'm going to rewrite that so you can see the negative. This would be the m, and here is b. We know that y equals mx plus b. B comes first alphabetically before m, and b stands for beginning, and m is how we move. So we need to begin at 16. So we'll just go up to 16. Here's 16 on the y-axis. And we'll put our line, or our dot, excuse me. There's our y-intercept, b. Then it says m is -4. Now we know m has to be in a fraction, rise over run. So we'd say -4 over 1. -4 is the rise, it's going to go up or down. 1 is the run, we're always going to run right. So we're going to go down 4 from 16. So 1, 2, 3, 4, that would give us a value of 12. So we're going to go down to 12, and then we're going to run right 1. And here is our dot, and this would be the graph of our line. What we have is a negative slope, and so it is falling. It's crossing the y-intercept at 16. It goes down 4 steps and runs right, down 4 and runs right, and we have our graph and we have the equation of a line. All we had to do, really, was find the slope, and then everything else was really straightforward. Now, I wanted to show you that we ended up with this equation, y equals -4x plus 16. So I'm going to quickly just kind of write this over here from if we chose m equals -4, and we chose the point 6, -8. We got y plus 8 equals -4 times x minus 6. And simplified it equal to y equals -4x plus 16 in slope-intercept form. So we have point-slope form and slope-intercept form given the slope and that given point. But what happens if we chose the different point? Would you end up with the same exact picture? Let's look at that really fast. So I'm going to keep the slope. We found that using both points. But now let's go ahead and change the point to see if we do indeed come up with the same exact scenario. This time we're going to pick the point 3, 4. So this time we're going to say this is x1 and this is y1. We're picking the other point because I told you already it doesn't matter which one we pick. Just got to pick one of the two. So now all we got to do is plug it into y minus y1 equals m times x minus x1. We can see that that's going to be the m value from over here. And we're going to take our 3 and we're going to plug it in for x1, and we're going to take our 4 and we're going to plug it in for y1. We should end up with the exact same scenario. Let's see. Y minus y1, we get a value of 4, equals m, which we already know to be negative 4. Let's plug that in. And then x minus x1 is the value of 3. So this is the point slope form given that point. But it should yield the same exact picture and same exact slope-intercept form, y equals mx plus b. So let's go ahead and see it. Now, on simplifying for this one, I moved the 8 over first, then I distributed. Let's distribute first and then move. So we can have different scenarios, different ways of simplifying. So if we simplify this time by first distributing and then moving, we'll end up in the same place. Let's make sure. So we have y minus 4 equals negative 4 times x is negative 4x. Negative 4 times negative 3. Two negatives make a positive, so we're left with a positive 12. Now we need to get y by itself. So let's go ahead and add 4 to both sides. Negative 4 and positive 4 wipe out inverse operations. And we have y equals negative 4x. And then plus a positive 12 and a positive 4 make a positive 16. Well, would you look at that? It's the exact same equation. It didn't matter which point you chose. So choose the one that you like best. If it was up to me, I'd choose the ones that are all positive. It's less work. You don't need to worry about the double negative. It's easier just to plug in positive numbers than it is to plug in negative numbers. But you get to choose which one you like the best. So step 1, you find the slope. Step 2, pick a point. Plug it into your point slope form. Y minus y1 equals m times x minus x1. Get your equation. If you're asked to sketch it, then get it into y equals mx plus b form, which means you need to get y by itself, and then you can just go ahead and identify your m and identify your b, plot your b on your y-intercept, and move with your slope. That's it. Let's look at a few more like this, and then we'll talk about how we write an equation of a line and get it into standard form. All right, so we are going to write the equation line and we're going to sketch it. So we're given 2 points. Step number 1, we need to find the slope. So here we go. M equals y2 minus y1 over x2 minus x1. What do we know? This will be x1 and y1 because it comes first. And the second point is x2 and y2 because it comes second. So here we go. We're just going to put our divided line and negative and negative. All we got to do is drop it into the formula. y2 is 4 and y1 is 1. And then x2 is 2 and x1 is 1. All we got to do is simplify it. 4 minus 1 is 3 and 2 minus 1 is 1, which means m is just the value of 3. Easy. Step number 2, pick a point. So we have to pick either 1, 1 or 2, 4. It's not going to make a difference. I'm going to choose the first one. It's easier. So we're going to pick the point 1, 1, and I'm going to label that x1, y1, and I'm going to change it in terms of colors. So you can see that I'm choosing it, but it really isn't going to make a difference. Step 3, we have y minus y1 equals m times x minus x1. All we got to do is drop everything in. And here's our m. And we're going to plug it in. And we have x1. We have x1 and we have y1 that go in as well. So y minus y1, which is 1, equals m, which we know is 3, times the quantity x minus x1, which is 1. Now, we wrote the equation of the line, and we're feeling pretty good about it. So it says write the equation of the line, but we probably want to get this into y equals mx plus b form. So it really comes down to preference. Do you want to distribute the 3 first, or do you want to add the 1 over? It really comes down to your choice. So if we have y minus 1 equals 3 times the quantity x minus 1, I'm going to distribute the 3 first. If I have the 3, and I'll bring that in, that gives us y minus 1 equals 3 times x is 3x. 3 times negative 1 is negative 3. I'm now going to add 1 to the other side. Negative 1, positive 1. Inverse operations, they wipe out. And we're left with y equals 3x, and negative 3 plus 1, they have opposite signs, so we subtract, and we get negative 2. This is the same exact equation of the same line, just written differently. Point-slope form, slope-intercept form. Our job now, sketch it. Here's the x-axis, here's the y-axis. Remember, this is our m, and this is our b. Now, m, again, we have our rise, and we have our run, and our b is negative 2. We always start with our b. So our beginning value is negative 2. So let's go to negative 2 on the y-axis. Here we are. And it says to use our m, our move, is 3. It says to go up 3, rise, and we're going to run right 1. So we're going to go 1, 2, 3, up, and then we're going to run 1 to the right. So we went 1, 2, 3 spaces to the rise, and 1 to the right. Connect the 2 dots. There's the graph or the sketch of the equation of that line. Both of these are perfect. This is just point-slope form. And this is y-intercept form, or slope-intercept, excuse me, not y-intercept. So this would be slope-intercept form. So point-slope, slope-intercept form. Both of them represent the same line. This is the same exact picture. You'll get the exact same graph, exact same slope-intercept form if you had chosen the second point. So now, let's look at the next one. What we have is we have 2 points. Step 1, m equals y2 minus y1 over x2 minus x1. I'm going to put in our division bar and our 2 negative dashes. Well, let's label. The first point will be x1 and y1 because it comes first. And our second point will be x2 and y2 because it becomes second. So now we're going to plug in y2 minus y1. y2 is 6, y1 is 0. And then x2 is 1, and x1 is 3. Our job now, simplify. 6 minus 0 is 6, and 1 minus 3 will equal negative 2. We can simplify that easily, and so we know that 2 goes into 6 3 times, so we can say this is negative 3. We can also say m equals negative 3 over 1, depending on how you want to write it. But there we have our rise, and we have our run. Notice we're going to go down 3, and we're going to run right 1. So step 2, we have to pick a point. It doesn't matter which point you pick. I always like to pick the easiest of the points, and anything with a 0 is easy. So I'm going to pick the point 3, 0. Now, it doesn't matter that it came first. Sometimes you just want to stick with the first one because x1, y1 is all ready to go. So here's this x1 value, and here's this y1 value, but I'm always going to choose the point that has the less number of negative values we see, and if you have a 0, it's super easy to plug into. So now, step 3. Y minus y1 equals m times x minus x1. We're going to take our m, and we're going to plug it in. And we're going to take our x1 and plug it in. We're going to take our y1 and plug it in. So y minus y1. y1 is 0. Well, that's super nice. Equals m, which we know to be negative 3, times the quantity x minus x1, which is 3. So here we go. We have the equation of the line in point-slope form, but we should probably simplify it. Y minus 0, well, it's just y, equals negative 3 times the quantity x minus 3. Well, let's go ahead and distribute. Negative 3 times x is negative 3x. Negative 3 times negative 3, two negatives make a positive, and we'll say 3 times 3 is 9. This is the equation of the line. You get the same exact equation if it was using the second point, 1, 6. So let's go ahead and sketch it. What do we know? Here is the x-axis and here is the y-axis. And I'm going to have to change that a bit to give myself a little bit more room. Let's put it right over here. So here's the x-axis and the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have our b value, which is 9, and we have our m value, which is negative 3. So we always go, b is for beginning, so we're going to go up to 9 and put our dot on the y-axis because b represents the y-intercept. And our m is negative 3. Now again, we're going to rise negative 3, which means we're going to go down the stairs. We're going to go down 3 spaces, and then we're going to run to the right 1. So we're going to go 1, 2, 3 down, and we're going to run right 1. So 1, 2, 3 over 1. Here we are. This was 9. This would be the value of 6. And we connect those two dots. And there's the equation of our line, or there's a sketch of our line. So all in all, very, very straightforward. You find the slope, you pick a point, you drop it into the formula, away it is. So now, let's look at the next question. We have the point negative 1, 2 and the point 4, 7. Well, let's go ahead and do step 1. Step 1 says m equals y2 minus y1 over x2 minus x1. Let's put the division bar there and our two negatives, and let's go ahead and label these guys. So we have x1 and y1 because they go first, and we have x2 and y2 because it's second. That's just the way it is. It's easy to keep things straight. So the first part says y2 minus y1. So y2 is 7, and y1 is 2. And then x2 minus x1, the x2 value is 4, and the x1 value is negative 1. Now, 7 minus 2, well, that's the value of 5. On the bottom, two negatives make a positive. Well, if two negatives make a positive, 4 plus 1 is 5. And 5 over 5 is 1, which means really it's 1 over 1, which is just the value of 1. No big deal. So m is 1. So now step 2, we need to pick a point. Negative 1, 2 or the point 4, 7. It doesn't matter which one you choose. Now these numbers are smaller. Negative 1 and 2 are smaller numbers, but there's a negative there. These are bigger numbers, but they're positive. So it really, really, really comes down to what you feel most comfortable using. If you don't mind plugging in negatives, go with the very first point. If it's the first point, it makes things easier because it's already labeled x1 and y1, which is what you need for your formula. So it might make things easier for you in terms of plugging in. So even though this one has a negative, these values are smaller than 4 and 7. When you start getting bigger numbers, distributing numbers could get tricky. If the slope was something like 7, 7 times 4 and 7 times 7 might make things bigger. Thankfully, the slope is only 1, so it's not going to matter in terms of distribution when you distribute to get your formula. But keep that in mind when you're picking a point. If you get to choose nice numbers, choose those. If you have a 0 in it, choose that one. But if you just want to stick with, pick the first one to keep it easy, pick the first one. So if we pick the first one, negative 1, 2, what we have is x1 and y1 labeled. So step 3, y minus y1 equals m times x minus x1. All we got to do is drop everything in. So here's our m, plugging in. Here is our x1 is going to go in here, and our y1 is going to go in there. So let's go ahead and substitute. Y minus y1 is 2. equals m, which is 1, times the quantity x minus x1, which is negative 1. So we've written the equation of the line, which is fabulous, but we probably should simplify it and clean it up. Here we've got two negatives make a positive. So y minus 2 equals 1 times x plus 1. Now, if we distribute 1, it's not going to change anything. 1 times anything keeps it the same. So we have y minus 2 equals x plus 1. All we got to do now is get that negative 2 and move it to the other side. So let's go ahead and add 2 to the other side. And negative 2 and positive 2, inverse operations, they wipe out. And we're left with y equals x, and then 1 plus 2 makes 3. So we have our equation of the line in slope-intercept form. Here we had it in point-slope form, which makes things nice. So it comes down to what you're being asked. If you leave it in point-slope form, you were done right here. Slope-intercept form, you needed to come here. So now, let's go ahead and sketch this line. What we know is y equals mx plus b. M is the value of 1, and b is the value of 3. It's the y-intercept. We always go with b for beginning. So 1, 2, 3. Here's our y-intercept. There's our b. Then it says m is the value of 1. Again, rise over run. We're going to rise up 1 because it's positive, and we're always going to run right, and it's that value of 1. So we're going to go up 1. So this is 3. We're going to go up to 4, and we're going to run right 1. Here's my dot. So we go up 1 and over 1. This is the picture, the graph of that line. Not so bad. Pretty straightforward. What we're going to do now is we're going to continue to write equations of lines. We're going to, given 2 points, we're going to write it in point-slope form, we're going to write it in standard form, and we're going to write it in slope-intercept form to make sure that we can get it whichever form we are being asked to do so. All right, so we are asked to write the equation of the line in the 3 forms that we know of for writing a line. Point-slope form, slope-intercept form, standard form. So the big thing is that we got to get it into one of the forms first. What's the first form we're going to get it into? Point-slope form, because we're given 2 points. It's the quickest and easiest way to do that. So, step 1, m equals y2 minus y1 over x2 minus x1. So all we've got to do is drop everything in. Put our 2 negative signs in there, and we know that this will be labeled, I'll just write it up top, x1 and y1. Here's x2 and y2. If you don't need to label them, don't label them. If you need to, do so. So what we have is y2 minus y1, so we've got 2 minus 0. And then x2 minus x1, we've got negative 1 minus 4. So negative 1 and 4. So let's simplify it. 2 minus 0 is 2. Negative 1 minus 4, they have the same sign, so add and keep the sign, and we're left with a negative 5. So we always put the negative up top. Always, always, always. So we say negative 2 over 5 is our slope, because we always want to be able to go rising up or down, and we're always going to run right. So the negative, by convention, always goes up top. So now we're going to pick one of the 2 points. It doesn't really matter which one. So if we pick, we'll grab the first one. 4, 0, not only is it the first one, but it makes things easier to make sure we have x1 and y1. But it also has the 0 in it, which is also pretty nice. So now step 3, we have y minus y1 equals m times x minus x1. So we are just going to plug in our slope and our point. Y minus y1 is 0 equals m, negative 2/5, times the quantity x minus x1, which is 4. This is point-slope form. So we've done the first part. So now let's get it into slope-intercept form. Well, what do we need to do? Y minus 0 is just y. So y equals negative 2/5 times the quantity x minus 4. So let's distribute. And we have y equals negative 2/5 times x is negative 2/5 x. Negative 2/5 times negative 4. Two negatives make a positive, which we know. And the same thing as 4 over 1. So we multiply our numerators, multiply our denominators. So 2 times 4 is 8. And 5 times 1 is 5. This would be slope-intercept form. Nice. Point-slope form, slope-intercept form, what do we got to do now? We need to get into standard form. What does standard form say? X and y have to be on the same side, and x has to be positive, as well as there can be no fractions anywhere in the problem. So what's the first thing we always do? We always get x and y on the same side. That is the very first step. So when we do that, we have y equals negative 2/5 x and then plus 8/5. Don't worry about the fractions or any negatives at this moment in time. Always get the x and y on the same side first, which means we got to move this entire thing over to the other side. So we're going to add negative 2/5 x because it's the opposite inverse operation. So we're going to add 2/5 x to the other side. Negative 2/5 x, positive 2/5 x, wipe out. And we are left with 2/5 x plus y equals 8/5. Now, x and y are on the same side. X is positive, but there's fractions. We're not allowed to have any fractions anywhere in the problem, which means we need to get rid of it. And we know how to get rid of denominators by multiplying the entire equation by that least common multiple, that least common denominator. What is the least common denominator there? 5. So we are going to multiply this entire equation by 5. By doing so, we should, if we did this correctly, get rid of our denominators, which means we have 5, and let's go ahead and write it, 5 times 2/5 x plus 5 times y equals 5 times 8/5. Again, we're distributing the 5 to every single piece in that equation. Now, 5 divided by 5, make one happy whole, and we're left with just 2x. 5 times y is 5y equals 5 divided by 5, one happy whole, and we're left with 8. We have an equation in standard form. So notice, point-slope form, really easy to get to. Find the slope, pick a point, drop it on in. Slope-intercept form, get it into y equals mx plus b. Standard form, x and y have to be on the same side. There can be no fractions, x must be positive. And so we've now walked ourselves through how do we write an equation of a line for all 3 different forms. Again, this one's the easiest, second easiest, maybe a little bit harder. So now, question number 10. We have the point 0, negative 1, and then the point 1, 4. The first thing we got to do, find the slope. So m equals y2 minus y1 over x2 minus x1. If we put our line and our subtraction signs, let's go ahead and label these. I'll just do it up top. We've got x1 and y1 because they're the first points, and x2 and y2 because they're the second. Makes things a little bit easier. So if we drop in, we've got y2 minus y1. We've got 4 minus a negative 1. So 4 minus a negative 1. x2 and x1. We have 1 minus 0. Well, all we got to do is simplify it. 4 minus a negative 1. 2 negatives make a positive. And we have 5. 1 minus 0 is 1. So we have the slope of just 5. Great. Step 2, I'll do it up here. So if we have step 1, and we'll do step 2. I need to pick a point. Why don't we just pick the first one? So 0, negative 1. It makes things easier because at least now we have x1 and y1 already labeled. M is 5. We got the point. We're ready to go. Step 3. Let's plug into the formula. Y minus y1 equals m times x minus x1. So we're going to plug in our 5. We're going to plug in our x1 and our y1. So we get y minus y1 is negative 1 equals m, which we found to be 5, and x minus x1 is the value of 0. Now, we would need to simplify this to make sure it is in point slope form. So two negatives here make a positive. We'd say y plus 1 equals 5 times the quantity x minus 0. This is point slope form. Done. Now, let's go ahead and get it into slope-intercept form. Well, what do you notice? X minus 0 is just x. Makes things really easy. So we have y plus 1 equals 5 times x. Because notice, x minus 0 goes away, or even if we distributed, it wouldn't make a difference. 5 times x, 5 times 0. So now all we got to do is move that 1 to the other side. So let's go ahead and subtract 1 to the other side. 1 and negative 1 wipe out. When we write these two values together, 5x and negative 1, they don't go together. So y equals 5x minus 1. This is slope-intercept. I'm going to abbreviate there. So we have point slope, we have slope-intercept form. So now we need standard form. What does that mean? We have x and y on the same side, no fractions, no x has to be positive. So the first thing we're going to do is I'm just going to put it up here. So y equals 5x minus 1. We need to get x and y on the same side. So let's go ahead and subtract 5x and get it on the side we need it. 5x and negative 5x do indeed wipe out because they're inverse operations. And we would say negative 5x plus y equals negative 1. So x and y are on the same side. We don't have any fractions, but we can't let x have a negative coefficient, which means we either are going to multiply the entire equation by a negative 1 or we're going to divide the entire equation by a negative 1. It's the same operation here. So what we're going to do is I'm just going to multiply the entire equation by a negative 1. In doing so, I am changing all of the signs. Negative 1 times negative 5x gives me 5x. Negative 1 times y gives me a value of negative y equals negative 1 times negative 1 is a positive 1, and this would be the equation in standard form, where x and y are on the same side, x is positive, no fractions. So we're learning to write the equation line depending on what form we are being asked to do so. Point slope form is the easiest. Slope intercept form is the next easiest to get into. And standard form, again, it depends on how quickly and easily you can manipulate them. But these are the three types of ways to write an equation of a line, and we're seeing how to do that. Let's look at two more questions like this, and then we'll talk about how we combine writing equations of lines with parallel and perpendicular lines. All right, so question number 11. We have the point negative 7, negative 1, and also negative 3, negative 2. First thing we're going to do is we're going to find our slopes. Let's label these. x1, y1, x2, y2, because there's the first and there's the second. So step 1, m equals y2 minus y1 over x2 minus x1. Put our division bar and our two negatives. Let's drop everything in. y2 is negative 2, and y1 is negative 1. x2, negative 3, x1, negative 7. Keep track of your negative signs. So now what do we see? Two negatives here make a positive. Negative 2 plus 1, well, it's going to give us a value of negative 1. And on the bottom down here, two negatives make a positive. And we have negative 3 plus 7, so we subtract 7 minus 3 and we get 4. So we have the slope of negative 1/4. Okay, and here we can say this is the rise and the run. So we would go down 1 and we'd run to the right 4. Step 2, we need to pick a point. Which point do we pick? It doesn't matter. They're both, all points are negative here. Doesn't matter at all. I'm just going to pick the first one to keep things easy. So we have negative 7 and negative 1. Here's x1 and here's y1. Step 3, let's drop it into point slope form. Y minus y1 equals m times x minus x1. So we have our x1 and our y1, which we can nicely drop in, and we have our slope of negative 1/4. So y minus y1 is negative 1 equals m, negative 1/4, times x minus x1, which is negative 7. All we got to do now is make sure that we get those signs, S-I-G-N, simplified. Two negatives make a positive. So we have y equals, or excuse me, y plus 1 equals negative 1/4. And here, once again, two negatives make a positive. And we have the quantity x plus 7. This is the equation of the line in point slope form. What are we going to do now? Well, we need to get into y-intercept, or excuse me, slope-intercept form. So we need to distribute and get y equals mx plus b. So we have y plus 1 equals, we have negative 1/4 and then x plus 7. We are going to distribute the negative 1/4. So we have y plus 1 equals negative 1/4 times x gives us negative 1/4 x. Negative 1/4 times 7, we multiply the numerators, and we get negative 7/4. So now all we got to do is get y by itself. So we are going to get rid of the 1 by subtracting. So we're going to subtract 1 to the other side. Then this is where things get a little tricky. We have to add fractions. So if we notice, what we have is y equals negative 1/4 x, but we somehow have to combine these two numbers together. Now they're both negative, so we know the answer is going to be negative, but because they both have the same sign, all we got to do is add and keep that sign. So 7/4 plus 1. We're adding and keeping the negative sign. Well, how do we do that? Well, we need to get common denominators. Well, currently, this is 7/4, and this is 1/1. We need to get that common denominator of 4. So we multiply top and bottom here by 4. So we have 7/4 plus 4/4. Well, now that they have the same denominator, we can add the numerators and keep the denominator the same. 7 plus 4 makes 11, so we get a value of 11/4. So the answer here would be negative 11/4. Notice we added the two numbers and kept the sign. So this is our slope-intercept form. Not so bad. So now we need to get it in standard form. So what that means is I'm just going to put it up here. We have y equals negative 1/4 x minus 11/4. The very first thing we have to do is get x and y on the same side. That is the very first thing that I would do. So let's go ahead and add 1/4 x to the left-hand side. Negative 1/4 and positive 1/4 inverse operations, they wipe out. So we have 1/4 x plus y equals negative 11/4. Now that x and y are on the same side, now we can deal with making sure x is positive, which it is, which is great, but we have a fraction. We need to get rid of it. So we're going to multiply the entire equation by that common denominator. And thankfully, that value that we need is 4. So we have, and then 1/4 x plus y equals negative 11/4. And we walked how to do that in a previous lesson, how we were talking about standard form and slope-intercept form, how we would need to get those common denominators if you need a refresher on how to do this. So we're going to distribute on in. So we have 4 times 1/4 x plus 4 times y equals 4 times negative 11/4. So 4 times 1/4, the 4's wipe out and we're left with just a positive x, plus 4 times y, so we have 4y, equals, again, 4/4 makes one happy whole, and we're left with negative 11. And this would be our standard form. So, given 2 points, find the slope, pick a point, drop it into point-slope form. Simplify to get into y equals mx plus b for slope-intercept form, and get x and y on the same side, no fractions, and the x is positive for standard form. Not so bad. So now, question number 12. We're given -4, -1, and the point 5, -1. What's the first thing we're going to do? Well, we should probably label and say this is x1 and y1, and this is x2 and y2. We need to find our slope. So m equals y2 minus y1 over x2 minus x1. So let's put that division line and our negative signs in. So y2 is negative 1, and y1 is negative 1. x2 is 5, and x1 is negative 4. So let's simplify it. What we see here is two negatives make a positive, so we're left with negative 1 plus 1. Well, negative 1 plus 1 is 0. And 5, minus a negative 4, two negatives make a positive, and 5 plus 4 is 9. But if you notice, 0 divided by any number is just going to be 0. Well, pick a point. Let's pick the first one. Negative 4, negative 1. Again, here's x1 and here's y1. Step 3, we plug it in. Y minus y1 equals m times x minus x1. We have our m. We have our point, x1, y1. Let's drop it on in. We have y minus, we've got that negative 1 there, so y minus negative 1 equals m, which is 0, times the quantity x minus x1, which is negative 4. Now, two negatives make a positive, and we have y plus 1 equals 0 times x minus a negative 4, two negatives make a positive, and we've got x plus 4. Now, technically, this is point-slope form, but we see a problem, don't we? So this is point-slope form, but what do we notice? 0 times anything is 0. So yes, this is point-slope. But we are smarter than the average bears, and we know we're probably not going to leave it like this. So let's take a gander. We have y plus 1 equals 0 times x plus 4. 0 times anything is 0. If we distribute the 0, we get y plus 1 equals 0. The whole right-hand side of the equation goes away, which means all we have left to do is get y by itself for slope-intercept form, which means we subtract 1 on the other side. Positive 1 and negative 1 wipe out, and we're left with y equals negative 1. This is slope-intercept form. Y equals, well, there is no mx plus b. If you wanted to even write it that way, we could have done the following, and we could say y equals 0x minus 1. M is 0. We found our y-intercept by simplifying quite nicely and saying 0 plus or minus 1 is negative 1, but it's the same exact idea. We just don't tend to write 0x. So this is the slope-intercept form. So what's standard form? Well, standard form is x and y on the same side. There is no x, so we can't get it on the same side. So slope-intercept form and standard form just happen to be the same thing. So slope-intercept form and y equals negative 1 is also standard form. If there's no second variable, we can only solve for 1. So this question came out pretty nice. Basically, every single form is the same. We could have left it like that in point-slope form, but who would leave it like that? Who would leave a slope with a 0 in it? You would want to simplify all of your values. It makes the most sense to always simplify. So point-slope form and standard form and slope-intercept form are all the same. Y equals negative 1. Why is that the case? Because notice the y coordinates of both those points were identical, which means when we subtract the two, we get 0, which means we have a horizontal line. When you're looking at the graph, here's x and here's y, we go to negative 1, and this is the horizontal line. It has a 0 slope. It's going to cross through that point, and we can even look at it. The point negative 4, negative 1 is right there, and the point 5, negative 1 is right here. So both of those points are on the line. Now, before we move on to the next set of questions, what would happen if I change this just a little bit? So imagine for a second that we had changed the coordinate, and I want to make sure that we know how to handle something like this. So let's say 12b. Let's change the coordinate to be -1, -4, and -1, 5. Well, when we find the slope this time, we have y2, which is 5, minus y1, -4, x2, which is -1, minus x1, which is -1. Here, two negatives make a positive, and we have 9, 5 plus 4. Here, two negatives make a positive. -1 plus 1 makes 0. So we're changing things a bit. Now over here, 0 on the top is okay. You can be an airhead, up high, nothing up top, but you cannot walk on air. You can't walk on nothing, which means this is undefined, which means we have a vertical line. So now what we're noticing is that you cannot write point-slope form. You cannot write slope-intercept form. You cannot write standard form for something that you cannot plug into y equals mx plus b or y minus y1. So what do we do in this scenario? Well, we notice they both have the same x coordinate, which means we have the equation x equals -1. This is point slope and slope intercept and standard all in one. So just like we saw over here, when we only have one variable, makes things easy. When it's not even a line that can be crossing the y-axis, then we have to deal with the fact that we can't get it into any of those forms. We only have one possibility. And if we graph those 2 points, we have -1, -4. Here's that point. And -1 and +5. Here's that point. Notice it is indeed the line x equals -1. So just kind of wanted to show you what you would do if you ever encountered something like this. Notice that either the x coordinates are the same, x equals -1, or the y coordinates are the same, y equals -1, depending on which values they give you. So now, let's kind of combine our knowledge that we learned previously about parallel and perpendicular lines with writing equations of lines all together. So we're still writing the equation in line, and we're going to leave it in whichever form we get it in. So it's either we can leave it in point-slope form, slope-intercept form, or standard form. You can get it in whatever form you would like, but we're just going to kind of get it to the point where we know we've got the equation. And then if we wanted to, we know how to manipulate it, as we've seen in the previous examples. So it says, the line passes through the point -1, 3, and is parallel to the graph 3x minus y equals 4. So to write an equation of a line, we need two things, a point and a slope. So let's write that down really fast. We need a point and we need the slope. Those are the two things you have to write the equation of a line. So at the very beginning, the line passes through the point. We have the point. Okay. So step 1, we have a point. -1, 3. What are we missing? Slope. Okay. It says parallel to the graph, 3x minus y equals 4. Well, what does parallel mean? Parallel means same slope. So that means the line that we're trying to find has the same slope as that line. Oh, well, if I can just find out what that slope is, then I know what the slope of my line's going to be because they have the same slope. So I need to find out what the slope of this line is. So let's go ahead and find that. We have 3x minus y equals 4. In its current form, which is standard form, we don't know what the slope is. We need to get into y equals mx plus b to find my slope. So let's go ahead. I'm going to change this question mark to just be an m. Our job is to find m. So the first thing I'm going to do is to get y by itself. There are so many different ways that you could go about doing it. I'm just going to move the 3x over, and then I'll deal with getting the y. But if you wanted to move the y over and then subtract the 4, go for it. So we are going to subtract 3x on both sides. 3x and negative 3x, inverse operations, they wipe out. We're left with negative y equals, they're not like terms, so we say negative 3x plus 4. Now, we need to get y by itself. Right now, it's got a negative 1 in front. So we're going to multiply everything by a negative 1. So y equals negative 3x and then plus 4. If we do that, we are going to be able to change all of our signs. Negative 1 times a negative y, two negatives make a positive, and we're left with y equals. Negative 1 times a negative 3x makes a positive 3x. Negative 1 times 4 is a negative 4. So now, do I need all of these? Is that the equation of the line that I want? No, 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 no. We are trying to find a line that has this point in the same slope as this one. So the only thing we need from here is the slope. This right here is my m. That's what I'm looking for. So now that I've been armed with a point and a slope, I can now write the equation of this given line. So step 3, I have my point, which was given to me, negative 1, 3, and I have my slope, which is m equals 3. So it's point slope form. All I got to do is plug it in. And then I'll just say y minus y1 equals m times x minus x1. I was always given the point. That was really easy. The only thing I had to find was the m. Now normally m, if we had 2 points, we'd use our slope formula. But for here, we knew it was parallel. All I had to do was identify what that slope was. So let's drop everything in. We have y minus y1, which is 3, equals m, which we found to be 3, and then x minus x1, which is negative 1. All I got to do is simplify. 2 negatives make a positive, and we are left with y minus 3 equals 3 times the quantity x plus 1. This is the equation of our line that goes through that point and is parallel to that line. So let's look to see, are they parallel? So here, if I get this one into slope-intercept form, so if I change this right here to a plus and I distribute, I get y minus 3 equals 3x plus 3 times 1 is 3. If I subtract, or if I add 3 to the other side, I have y equals 3x plus 6. So now notice, these lines, if I have 3x minus 4, I have a negative 4, and then 1, 2, 3, up 1 over 1. There's the first line. And then this one, 1, 2, 3, 4, 5, 6, and then up 3 and over 1. These two lines are indeed parallel to each other. They have the same slope. This one has a slope of 3, this one has a slope of 3, but they have different points. And that's what we were trying to do. So we had a point. We needed to find the slope by manipulating the other equation, knowing that parallel means same slope. Grab that slope, grab the point that was given, drop it into point slope form, and we have our answer. I just wanted to make sure that we could see they really are two parallel lines. So now let's look at question number 14. It says, the line that is parallel to the graph and contains the point that's given. Now, what two things do you need to write an equation of a line? You need a point, you need a slope. Well, you have a point, great. What don't you have? Slope. What did they give you? They told us that it's parallel, which means it's the same slope as that one. So we need to find the slope. So to find the slope, we need to solve for y equals mx plus b. So x minus 2y plus 7 equals 0. We need to get y by itself. So I'm going to do one thing in one step. So I'm going to move the x, and I'm going to move the constant. So I'm going to subtract the x, and I'm going to subtract the constant all in one shot. You can do it in stages if you want to. X and negative x, inverse operations. 7 and negative 7, inverse operations. So we have negative 2y equals, and then 0 and negative x minus 7 just gives us negative x minus 7. Our job now to get y by itself. Let's divide everything we see by a negative 2. Divide by a negative 2 for every single term. Negative 2 and negative 2. Two negatives make a positive, but more importantly, 2 divided by 2 makes one happy whole. Y equals. Here, 2 negatives make a positive, and we're left with x over 2. Here, 2 negatives make a positive, and we're left with just a positive 7 halves. Now, at this moment in time, it doesn't seem as obvious that we have y equals mx plus b. But we do, because we know how to rewrite this. We know this is the same thing as y equals, there's an understood 1 right there. We can pull this out and say this is 1/2 x plus 7 halves. What we've now discovered quite nicely is that this is m. This is the value I need. So now I have the point which they gave us as negative 4, 0. And I have the slope which we just found to be m equals 1/2. Got everything I need. It's going to go through that point with the same slope as this one, so let's drop it on in. Y minus y1 equals m times x minus x1. So we have y minus y1, which is 0, equals m 1/2 times x minus x1, which is negative 4. All you got to do now is simplify it. Y minus 0, well, that's just y. That's nice. Equals, and here 2 negatives make a positive. Okay, so we can say 1/2 times the quantity x plus 4. This is the equation of the line. You can simplify it if you want to and say this is 1/2 x plus 2, meaning we're going to distribute the values because 1/2 times 4 simplifies to 2. You can write it any which way you want to, but this is the equation of the line. We can then write it in simplified form of 1/2 x plus 2. If you distribute, it's up to you. You can put it in standard form if you want to, but all we had to do was find the slope knowing that parallel meant same slope. Well, what happens if it's perpendicular? Well, that would be the negative reciprocal slope, the negative flip. Let's look at a few questions like that. All right, so it says the line that passes through the point 4, negative 7 and is perpendicular to the graph of 2x plus y equals 15. So what two things do we need to write an equation of a line? You need a point and a slope. These are the two things you have to have. Well, do you have a point? Yeah, check. We have a point. What don't we have? I don't see a slope. What's the one thing they did tell us, though? They told us it was perpendicular. And perpendicular means negative reciprocal slope. Meaning if we can find the slope, all we got to do is flip it and change its sign. So let's go and find what the slope of this line is, and then we can flip and change the sign. Here we go. So we have 2x plus y equals 15. Let's get this into y equals mx plus b form. So I'm going to subtract 2x to the other side. So inverse operations, those wipe out, and we are left with y equals negative 2x plus 15. Now, what we can see right now is that this is y equals mx plus b. If I wanted parallel slope, so I'm just going to use the symbol for parallel. So parallel slope, we would say m equals negative 2. But we want perpendicular slope. Perpendicular slope means we want m equals, and we're going to flip that. So right now what we have is negative 2 over 1. So to flip it, we would say we're going to put this on the bottom, and we're going to change its sign. Currently it's negative. We want it to be the opposite sign, so it's going to be positive. Right now it's a 2. We're going to flip it to make it 1/2. So again, if we kind of just quick review, if parallel slope was, so these are just examples. If the parallel slope was 3/5, the perpendicular slope would be to flip the fraction to make 5/3 and change the sign. If the parallel slope was -7, the perpendicular slope would be to flip the fraction and change the sign. So all we're doing is flipping the fraction. Once again, if the parallel slope was 1/2, the perpendicular slope would be to flip it and change the sign to say -2. So what we're doing here is we're flipping and changing the sign to get the slope that we want. And we learned how to do this in the previous lesson, but if you need a refresher, there you have it. So now, let's use the slope that we need and the point that we are given to write the equation. So the perpendicular slope is this one. So now we have a point which was given to us of 4, -7, and we have a slope, which is the perpendicular slope, and we know it is the negative reciprocal. We change the sign and we flip the fraction. So let's drop it on in. Y minus y1 equals m times x minus x1. So here we go. Y minus -7 equals m, which is 1/2, times the quantity x minus x1, which is the value of 4. So now let's just simplify it. Two negatives here make a positive, and so we have y plus 7 equals 1/2 times the quantity x minus 4, and this is the equation of the line that passes through that point and is perpendicular to 2x plus y equals 15. Not so bad. Now let's look at question number 16. It says the line whose x-intercept is -6 and y-intercept is 2. Okay, well, we could graph it. We can say, okay, here's the x-axis, here's the y-axis. It's going to intersect the x-axis at -6, so here's -6 for the x-intercept. And the y-intercept is 2. So there's the line. But I don't know what the equation is, so maybe we need to write ordered pairs. The x-intercept. Well, the x-intercept, we know, is x comma 0. Well, they told us what the x-intercept is. It's -6. So we have the point -6, 0 is the x-intercept. And we know that the y-intercept is 0y, meaning I'm only going to be on the y-axis, and they're telling you it's a value of 2. So they're giving you another point, and they're saying 0, 2. Hey, they were super sneaky, weren't they? They actually gave you 2 ordered pairs. Oh, we know how to write the equation of a line when we're given 2 ordered pairs. Here's x1, here's y1, here's x2, and here's y2. Step 1, find the slope. y2 minus y1 over x2 minus x1. And let's drop everything in. y2 minus y1, 2 minus 0. And then x2, 0 minus -6. So 0 minus a -6. So 2 minus 0 is 2. And then 2 negatives here make a positive, it's left for 6. And we can simplify 2, 6 to say this is the same thing as 1/3, because 2 goes into 2 one time and 2 goes into 6 3 times. So now we found m. And then step 2, we pick one of our points. Either it's we pick the x-intercept or we pick the y-intercept. It doesn't matter. If we pick the x-intercept, let's choose -6, 0. So we're going to pick that one. And then step 3, let's plug it on in. Y minus y1 equals m times x minus x1. So y minus 0 equals m, 1/3, times the quantity x minus x1, which we know is to be -6. So what we can do here is we can simplify it. Y minus 0 is just y equals, here 2 negatives make a positive, so we have 1/3 times the quantity x plus 6. Now this is a beautiful answer. Could we simplify it? Sure we could. If we distribute, we would get y equals 1/3 x, and then 1/3 times 6, 3 goes into 6 2 times, and we get y equals 2. Or excuse me, y equals 1/3 x plus 2. Now notice, that is indeed the y-intercept, so we know we've done that right because we have y equals mx plus b. Now, was this the only way that we could have done it? Notice that we graphed, and we are also pretty clever when it comes to being able to write the equation of the line or find the slope given its graph. We know that b was just 2, so there's the b. But couldn't we have done the rise over run to get what we wanted? Sure. Notice, we could have made that little triangle that we've done before, and we know this is the run, and this is the rise. We run 6, and we rise 2. So m equals, again, the rise over the run, and we can see that we're rising 2, and we're running 6. Notice we get 1/3. If we had m and we had b, we could have easily just dropped it on in that way. So many different ways of going about doing it. We could have done the 2 ordered pairs. We could have used our graph. We could have plugged in one point into y equals mx plus b. So many possibilities. You get the same answer in the end. Let's look at one more question together. All right, so we have a line that passes through the point -4, -5, and has the same y-intercept as the graph x plus 3y plus 9 equals 0. So the two things you need to write in an equation of a line is a point and a slope. Well, you're given the point, and you're not given the slope. You're only told that it has the same y-intercept. Y-intercept is the point 0y. Some of us will refer to it as 0b, depending on which way we talk about it. But we have to find what that value is. If anything, at least maybe we can get 2 points, and then we can go from there. So the first thing that we know is that we need to find the y-intercept for this graph. So x plus 3y plus 9 equals 0. I'm going to subtract the x and the 9 to the other side in one shot. So we have minus x minus 9 minus x minus 9 on either side. X and negative x inverse operations, 9 and negative 9 inverse operations. So we have 3y equals, over here, just negative x minus 9. Now I need to get y by itself, so I'm going to divide everything by 3. 3 divided by 3 makes 1 happy whole, and I'm left with y equals, here we can't simplify, but we can write this as negative 1/3 x. And here, negative 9 and 3, 3 goes into 9 3 times, so we say negative 3. Now, we aren't saying that it has the same slope. We're only saying it has the same y-intercept. So notice this right here is b equals negative 3. This is the y-intercept, which means it is the ordered pair 0, negative 3. So we now have a new point, 0, negative 3, and a point that was given. So what we have is -4, -5, and the point 0, negative 3. Now, we can go about and use the steps and go, okay, number 1, m equals y2 minus y1 over x2 minus x1. Step 2, we pick a point. So probably I would choose -4, -5, because that's the point that was given to us. In step 3, y minus y1 equals m times x minus x1. This would be the steps in the procedure that we would go about doing this problem if we were given 2 ordered pairs. But I do want to show you in the last question that you can change it up a little bit, and you don't have to always use this formula if you don't want to, especially if they did give you the y-intercept. So what do you know? Alternate method. We know that y equals mx plus b. What did we just find? You are given a point -4, -5, and you have found b to be -3. We know that because it has the same y-intercept, and you already did all the work over here. So what we can do is we can take these values and say this is x, and this is y, and that's b, and I can plug it in. So we could do it, we could plug into the equation y equals mx plus b just as easily as we can plug into y minus y1 equals m times x minus x1. I find this one a little bit longer in terms of solving, and that's why I don't tend to use this method, and I like this one better. But I want to show it to you so you can have different possibilities. And you might find that this method is a little bit easier for you. So I'm going to take the point, and I'm going to take b, which I just found to be -3, and I'm going to plug it in. So we have our y value is -5 equals m times our x value to be -4, and our b value to be -3. So now for this one, I'm solving for m. So let's go ahead and do that. If we simplify really fast, we have -5 equals m times -4 is -4m, and then plus -3 is just -3. I just need to solve for m at this moment in time. So let's go ahead and add 3 to the other side. -3, +3, wipe out. -5 plus 3, that will give us a value of -2, and then equals -4m. To get m by itself, I'm going to divide both sides by -4. Here, 2 negatives make a positive. 4 divided by 4 makes 1 happy whole, and I'm left with m by itself, which is what I want. Over here, we've got -2 divided by 4. 2 negatives make a positive. 2/4 is the same thing as 1/2. So now I have m, and I have b. I can write the equation. Y equals mx plus b. Y equals 1/2 x plus or -3 or -3, and this is the equation of the line. If we had gone about doing it this way, we would have gotten m to be 1/2, just like we saw here, because again, -3 minus a -8, and again, I'll go ahead and show it to you so you can see it. So we have -3 minus a -5, and then 0 minus a -4. 2 negatives make a positive. 5 minus 3 is 2. And then 2 negatives here make a positive and 4, and we're left with 1/2, just like we thought. We have our point. So we would say y minus y1, which is -5, equals m 1/2, x minus x1, which is -4. Here, 2 negatives make a positive. And so we have y plus 5 equals 1/2 times x. The 2 negatives make a positive, so we say plus 4. And if we solve for y equals mx plus b, guess what? Y equals 1/2 x minus 3. Same exact equation, just 2 different ways of doing it. And that's all there is to writing the equation of a line. What are the 2 things you need? You need a point, you need a slope, and you drop it into the formula. And if you want more algebra videos just like this one, head over to Calcworkshop.com. So now I've got a question for you. Which method do you like the best? Point slope, slope-intercept, or standard form? Please leave me a comment below, and I'll see you in the next video. Guide of where this is the same. I can go. People are like, what is wrong with her? Thanks.